Okay, AP Statistics. In this video, we are in Unit 3 in the book. It is Section 4.2. We're going to talk about experiments in this particular video. All right, so the first thing we need to do is establish the difference between an observational study and an experiment. So an observational study means we are just observing individuals. Okay, so in an observational study, we observe individuals, we measure variables of interest, but this is the important part. We do not attempt to influence the responses. In other words, we're not manipulating anything. So that is one of the major differences between observational studies and experiments, because in an experiment, right down here, I'm going to talk about that. An experiment deliberately imposes treatments on the individuals to measure their responses. So with an experiment, the statistician or the researcher, whoever is conducting the experiment, they are going to interact with these people, at least, in the very least, to impose some kind of treatment on whoever's participating. Observational study, you just sit back and you watch what's happening. Oftentimes, we use an observational study if we want to gather data on something that it wouldn't be ethical to perform an experiment. For instance, if you wanted to observe the effects of drug and alcohol abuse or something like that, even if people volunteer to take drugs and alcohol, it's not ethical to randomly impose that treatment on them. So for things like that, anything for which it would be unethical to conduct an experiment, observational studies are really useful. So just like we talked about in Unit 2, we do have a response variable and an explanatory variable. Response variables are going to measure an outcome of a study, and an explanatory variable is going to possibly help explain or predict what changes we see in the response variable. So another word that comes up as we're talking about experiments and observational studies is this idea of confounding. And this just occurs when we have two variables that are associated in such a way that their effects on a response variable cannot be distinguished. So what does that mean? And it distinguished from each other. Sorry, I should have finished that sentence. Okay, so for instance, I didn't know if you're aware of this, but there are two things that happen to have a positive correlation, all right? And those things are ice cream sales and drowning deaths. I know, it's all fun around here. Sorry for the deep issue. All right, so drowning deaths and ice cream sales. Incidentally, this is a true relationship. As one of them increases, so does the other one. But would it make sense to say that these two things are related to each other? No, there's something else, a confounding variable that actually makes it look like these two things have a relationship, and that's the weather. Because when it gets warmer, people tend to buy more ice cream, and when it gets warmer, people tend to find water to be in, therefore showing that it looks like there's a positive relationship between these two values or variables, and there isn't, okay? They just happen to be confounded by the fact that the weather is causing both of them to increase. So you have to be careful with stuff like that. You have to pay attention to that. Okay, a placebo. A placebo is something that you probably are already familiar with. It is going to be one of the treatments we talk about. It's a treatment that has no active ingredient. So when might this be useful to me? Well, if I am, let's say, doing a drug study, and I call for people who to volunteer who suffer from migraine headaches, and I've got a new drug I want to try out on them, but I'm really concerned about the placebo effect. I'm worried about the fact that if I tell them it's some kind of wonder drug, that they're going to think their headache is getting better. So I may want to randomly give some of them a placebo and some of them the actual treatment. So the placebo is just making people think they're taking something when they're really not. And we're going to talk about that in more detail here in a moment. Okay, so keep in mind that when you're dealing with an observational study, all you can really do is gather data and kind of look at trends, kind of like our linear regression, all right? All we can really do is observe what's happening and say, you know, I can probably make a prediction of something I think might happen, but it really doesn't help me with cause and effect. The only thing that can ever show me cause and effect is going to be a well-designed experiment. So that leads us into the language of experiments. What kinds of things are we talking about here? So anytime we have a specific condition or something that we want to apply to an individual in our experiment, that specific condition that is applied is called a treatment. So just like in that drug study I was talking about, well, if I want to try out this new migraine headache drug, that's my treatment, and then the placebo might be the other treatment. So treatments are just something that is imposed upon the participants or individuals in an experiment. So if an experiment has several explanatory variables, a treatment is a combination of specific values of these variables. Please keep in mind when I talk about an experimental unit, that is the object to which a treatment is randomly being assigned. Okay, when the experimental units are human beings, they are often called subjects. Okay, so the participants in an experiment are called subjects, or if they're items, experimental units, whatever you're conducting an experiment on, whatever you're randomly assigning to treatments. Okay, so within this idea of experiments, we are going to talk about factors and levels. So a factor is any explanatory variable that is going to be manipulated. So this is what is being manipulated, and it may cause a change in the response variable, and the different values of that factor are referred to as levels. And then, of course, all of the levels added up together show me my treatments. So let's say I'm conducting an experiment and I'm going to use that headache medicine. Okay, so I have a headache drug that I'm going to try out. And let's say I want to see how well it or how quickly it cures a headache based on the dose of drug. So let's say I've got the headache drug itself, that is going to be the factor, and let's say I've got a couple of levels. Let's say I've got it at a 50 milligram and a 100 milligram. Well, these would be the levels of that factor. So the possible treatments that someone would be able to be randomly selected for are going to be this level or this level. So that would be a total of 2 treatments. Okay, that's how that works. Now let's try something else. Let's say I am a nutritionist and I want to see the effects of exercise and sleep on, on diet. Okay, so I want to see the effects of sleep, of exercise and sleep on diet, health, nutrition, whatever. Okay, exercise and sleep are my factors. Okay, so I have 2 factors. And within each of those, I'm going to assign people either 0 minutes of exercise a day, 30 minutes of exercise a day, or 60 minutes of exercise a day. All right, and for sleep, I'm going to assign people either 6 hours a night or 8 hours a night. Okay, so in exercise now I have 3 levels, and in sleep I have 2 levels. So what are all of the possible treatments that I have? Well, I can assign someone 0 minutes and 6 hours of sleep, or 0 and 8, or I can assign 30 minutes and 6 or 8, or I can assign someone 60 minutes of exercise and 6 or 8. Well, notice that there are 6 lines there, so there are 6 treatments. How do you get treatments? You take your levels and you multiply them. That's how you get the number of treatments. So over here, we just had 2. Over here, we had 6. All right, so that's that just shows you a little bit of what levels, factors, and treatments look like. Obviously, the biggest problem you're going to face is keeping those words untangled. So factors, those are your overall, okay, what I'm thinking of as my explanatory variables. Within that, you have your levels, and then your total factors and levels, those are going to be your treatments. Okay, that's how this works. FLT. Flight. Ah, there you go.